Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to get right back into trying to get this Plexus P20 working again. If you haven't seen part 1 and part 2 yet, I recommend you watch those first. As usual, I'll be continuing off where we left off in part 2. But for a quick recap, this computer is a Plexus P20. It's from 1985 and it's a dual processor Motorola 6810 Unix office computer. It's designed to support up to 8 concurrent users hooked up through serial terminals. This has SCSI, 2 megs of RAM, tape drive, floppy drive, and an internal hard drive. As of the making of this video, there's basically zero information about this machine except for a little brochure that I was able to find on BitSavers that talks about the computer, but other than just some specs, that's basically it. In part 1, I was able to recover the data off the hard drive in this, which I've remounted inside the computer. So with a good dump of the operating system that was on it, we actually have a hope to get this computer working. Without an operating system, there would be no way to get this computer working beyond just a simple boot ROM. In part 2, I worked on the power supplies to make sure that this thing could actually run safely. And then I was able to get this thing powered up and we actually got connected to the boot ROM. Now the hard drive was disconnected while I was doing this, but at least I was able to issue commands after doing some RS-232 troubleshooting on the motherboard, and we're up and running. And we are nearly there for actually booting the system. So in today's video, I put the hard drive back in and I want to see if I can get this thing actually booted into the operating system to see what this computer is all about. So without further ado, let's get right to it. As a reminder, this Fujitsu hard drive is MFM or SD506 interface, but it is actually connected through these cables to a SCSI interposer that is mounted inside this computer between the power supply and the motherboard. And on the motherboard side, this is a 50-pin SCSI connection which goes to that interposer board, which does the translation between MFM and the SCSI interface that this motherboard uses. The floppy drive on this computer, which is a Sugart double-sided double-density 80-track drive, so about 720K, is also connected to that same SCSI interposer, so that essentially this is a SCSI floppy drive, even though this is a standard PC floppy drive. So if this drive doesn't work properly, I can swap it out with any standard PC floppy drive. I have a few things that I'm worried about when it comes to powering this on. We know the hard drive is working. I think the SCSI interposer works, although there's no real way to test that. I think the bigger problem is that the motherboard lost its configuration settings because the battery that was on there died a long time ago. And I am concerned that the drive parameters, the heads and cylinders and whatnot, is stored inside that config variables in the battery backed up RAM. And since it's lost, I just don't know if the system is going to be able to read those off this hard drive once it spins up and configure those, because the interposer does require those configurations set. Now in the boot ROM, you can run some commands, but unfortunately they don't seem to be embedded into the boot ROM. They seem to want to load from the disk itself or potentially from the tape drive. Now the operating system for this machine seems to be distributed on a tape. So if you have a hard drive crash and you need to reinstall your OS from scratch, you use the tape drive to format the new hard drive, make a new file system, and then restore it all back onto the drive. We of course don't have the operating system tape, so there's no way for me to run any of those commands unless they're able to be loaded off the disk. When we turn on this computer, if it's not able to configure the drive based on like the first sector on this disk, which it should be able to access, and it's looking for us to run commands off tape, we're unfortunately going to be dead in the water. So with all that said, it's now time to actually hook this thing back up to my lab machine and power, and hopefully we can get this thing working again. I had some issues in part 2 where this machine didn't always pass diagnostics, or got stuck in a boot loop, or I couldn't type commands on the keyboard. So hopefully all of that is behind us and this computer starts up normally, and then it's able to actually just boot the operating system without me having to type in any commands or have the tape to do it. So let's do that right now. All right, I'm all set up with the capture. Putty is up, everything is ready to go. I got my screwdriver ready, and it's like an old stolen car here. I'm gonna turn this to the reset position. I'm gonna let this all spin up for a second. The hard drive is spinning up. That's a good sign, right? All right, that's long enough. I'm gonna turn this to the run position. There we go. It didn't do any kind of boot looping. Oh yeah, we got one Plexus, that's good. Here we go. It's going to run the diagnostics. Let's hope that it doesn't do any fails. We were getting multi-bus failures yesterday, and we got one main board failure, but then generally it was working okay. Okay. Self-test complete. Oh, it sees the hard drive. SC0 and SC7. I guess one is the tape drive, or no, I don't know actually. SC0, I don't know if that's the hard drive, and SC7, that just might be the interposer. But the thing is, the tape drive is connected, and that's a SCSI device as well. And I think that should show up as some kind of SCSI device. Now, I know I'm not typing anything here, I'm just waiting, but I don't think it's ready. Oh, I hit enter, and it says /Unix. Oh, I think it's doing something. The hard drive LED is flashing on there. You gotta be kidding me. No way. I know you can't see the hard drive LED. It's sort of blocked behind the case itself. But system 5.2 R8 single user mode. I was so concerned about the root password when that was not actually anything to worry about. Oh wait, no. It's gone to run level 2, which is not single user mode. Is the date correct? It is not correct. Oh, this is amazing. Date format, mod Y HR MN and then brackets year. What? I think what it's asking for is month, day, hour, minute, and then year optionally at the end. So we have 5/23, time is 1707, and then the year, I guess, yeah, okay, so it has an example right here, I just noticed that. So the year is 2 digits at the end. So the year is 24. Is it gonna take this date? It did not take the year correctly. It thinks it's 1970, so I'm gonna say no, and we're gonna type this again. I'm just gonna paste in their example here. This might not be Y2K compatible. Oh yeah, so that is how it works. 86 was the year. There we go, I put in May 23rd, which shows up as Thursday, 1996. So that is close enough. I can't believe this thing is working. Do you wanna check the file system? Sure, let's check the file system. Oh, wow. Okay, so couple things. It looks like it absolutely loaded the parameters for the hard drive off sector 0. Some of my patrons theorized that's exactly what would happen, and it is what happened. Oh, that is so cool. You can see the blinky blinky lights as well. They're doing stuff. That is freaking awesome. I am absolutely flabbergasted that this thing just freaking works. I mean, obviously I had to do a little bit of work there. I was trying to be super careful the whole time with this system. I wanted to make sure I preserved the data on the hard drive, which is why I did all that stuff in the first part. And then obviously the power supply stuff in part 2 was worthwhile because now the system seemed to fire right up and is working stably. So let's look at what's happening here. So far, nothing looks out of the ordinary. So we have what looks like 2 partitions, right? Root volume and /user volume. Warning, mounting /user as user. Move cannot access something or other. Oh, that's kind of weird. Initializing RKER. Archer. What's Archer? Moving on, LP scheduler. Unix system 5.2, copyright 1986. So this obviously has a little bit of an update. Okay, console login. So we got root. So back in part 1, when I recovered the OS off this drive, I knew that the root password might be a problem if we ever got this computer booted. So what I did is I looked for the password files in the binary dump of the hard drive, and I was able to extract what you see here on the screen, which is different hashed passwords that look like from various password files that were all over this machine. So I went over to Patreon and I asked my patrons if someone could reverse the password so that when this situation happened, I will be able to log in. And in no time flat, my patron Hein came back with the answers. And it seems that the password that was being used on this system for the root account is just half pint or blank. It might be blank or half pint. So I think the first thing we can do here is let's just try out root. Oh, I put an extra slash there. That's not gonna work. It did work. I don't know, I accidentally typed the backslash and then I just hit enter for blank and you gotta be kidding me. What? Let's try that again. So root, and we hit enter for blank. Oh, and that works. There's no password. So all that work wasn't even necessary. Let's try that here account. Let's see if that is a real account. And we'll put half pint as the password. That works as well. So, and it put us, that is so cool. Yeah, there we are. We were in the root directory. So let's just take a look at what is the actual password file on this machine. Oh, wow. It's a bunch of accounts. So if we compare this, well, the interesting thing is looking at what I extracted doesn't seem to match what's actually here. We have RVXY, and that seems to be on this /dev root, but unless I'm missing it, I don't see it on any of the other root accounts here. So there are a few other accounts in here. There's one here called off. We also have what are obviously the users on this particular system: Woody, Work, Ed, Lack, Guest, Jan, Colleen, Bob, and Jim. Hi to any of you if you're watching this video. Now this machine obviously belonged to a company. There would be no reason why like a home user would ever have had this computer. So I don't want to show any like personal information or any company information that's on here, just to protect the people that were originally using this machine. So there might be a little bit of blurring that has to go on the console output of this machine. So let's poke around the system a little bit. I've never used anything as old as this. So these are the processes. I think these are all of them that are running right now. You can see here we're running the PS command from the console, and we have TTY1 and TTY2, and it's running Getty. So that means that there should be at least 2 more console ports active on the back of this thing. Now it looks like we're running shell, but I think C shell is actually installed on this. Yeah, okay, we have C shell as well. I'm not super familiar with C shell. I know bash, of course, because that's what's used on Linux these days. So I'm curious, we saw in like that instruction manual that we would have to run the dconfig command, but that doesn't appear to be anything we can run. I popped over to user bin just to see what's in here. There's a whole bunch of stuff that starts with a Q. Qcrypt and Qconvert and Qdraw. And one of them here is QOffice. And I'm wondering if this is like some kind of an office suite that's on here. What I don't find immediately is that dconfig command to set up the configuration of the machine. In case anyone is curious, uname reports sys 5.2, Unix 1.2, R8, M68. We have a /user directory, and in here appears to be stuff related to the user account. And yes, it seems like /user is the equivalent of /home on a more modern Linux distribution. There's a help program here, help stuck. If you know the value of a system error, you can look up the description in intro 2. If you don't know the error number, you don't understand what's going on, try the following. Make sure the answer isn't in the documentation. Well, we don't have that. Try to write to anyone logged in as ADM. So I guess this is like you could write to all kind of thing. Step 3, contact your Unix counselor. And step 4, file an MR. See the system administrator for instructions. What's MR? You know, I think that intro 2 is a man page, but if I type man intro, we don't get anything. It's just telling us bad directory for catman. Yeah, there's no catman directory here. But there's a doc directory. Yeah, we have a few things in here. All right, so the README says, this letter is designed to highlight the new features of Q1 and QOffice. Operational descriptions of each feature are contained in the July update of QOffice. Q1 has multi-column text, graphics space reservation, index generator. Yeah, integrated menu system, new features. Okay, so it's some kind of office suite. I wouldn't be surprised if this QOffice is the only thing that's actually on here. All right, I just wanted to see if there's a C compiler on here. Let's see, is the which command on here? No, that's not there. So CC obviously would be a C compiler, and it does seem to be on here. And yep, there's a linker as well. So that means that we could probably port some stuff to this machine. All right, so this is weird. We have a directory here, 2020, which I went into. What's the deal with this? 2017? Was someone using this in 2017? I noticed when we looked at the user directory, /user, where I had the user accounts, those had date stamps around 1989. But 2017, that's kind of unusual. So the file in here called releases.txt, technical notes for 2020 on the Plexus P35. This looks like it's some kind of a graphic thing for plotters or terminals that support graphics like the VT420. We have a directory in here called tutor, and inside of here are just a bunch of files, and they all have 2017 date stamps. I need to find a log file. There's got to be logs on here somewhere, and we can try to see if this thing really did boot up in 2017. You know, unfortunately, the find command returned absolutely nothing. So unless I have the syntax wrong, Let's try that again, but I will look for those TMF files just to make sure that it's actually finding them. All right, obviously my syntax is wrong because it didn't find the TMF files. I think what I'm going to do now is stop the recording, and I'm going to start poking around the hard drive and take some notes, try to figure out what I can figure on this machine, see if I can find some log files or any other evidence of when this machine was actually last used. I also want to try to get the floppy drive working, because if we're going to try to get files off and on this machine, that might be one of the best ways. It doesn't look like Kermit or Z-Modem or any like file transfer utilities are on this thing. So that's another way we could transfer files, is over the serial connection. So I'm going to do some more poking around and see what I can figure out, and then we'll be back. Well, unfortunately, that went down the drain very quickly. You can see behind me, the machine is sitting there. I actually put the lid back on it because I wanted to make sure the computer was getting good cooling. So with the main fan hooked up, the motherboard was going to get lots of air around it. I actually did that because while I was poking around on the hard drive trying to look for interesting stuff, the computer crashed. I was about to show you the crash messages, but might as well show you the things that I found poking around on the hard drive. So inside the etc directory, there was this config file that talked about the various serial ports on the back. So first thing it does is set up the console on serial 0, which is the one I was connected to, and then it goes ahead and runs Getty on all the other serial ports, so 1 through 7. Oddly enough, 4 is set to 1200 baud. Don't really know why. The rest are 9600. Continuing to poke around, I found /user/ADM, and this was some logs and stuff. Unfortunately, most of these files just have 0 bytes to them, and even the ones that have like 68 bytes in them really didn't have anything in them at all, except for just a header. And the only file that had anything, well, that was actually in there, was su log. But inside that, all you really got was this. If we scroll down, we can see like Janet-root. I don't know what that exactly means here. Ed, yeah, I think that's one of the usernames, right? Ed. But unfortunately, there's no years on any of this. Now, the timestamp, I didn't save the timestamp, but it was like 1989, I think. And unfortunately, that was it for log files. Now, there was a games directory as well, and inside of here was a bunch of games that probably all come with AT&T Unix System 5 Release 2. One of them was called Robots, and it looks like we have various users playing stuff. Now, Woody is one of the usernames on this machine, and there's a lib directory right here, and that contained the high score file. And the high score file did also have a date of, I think, 1989 or 88 or something like that. So it shows that people were actually playing games. Now, when I was poking around some more on the hard drive, I went to the include directory, I typed S, and it says command not found, and then the computer crashed. We got this remote kernel bus error, like some register stuff. The remote kernel just says halted, and it ended up at this prompt here with a plus. And I could type stuff, but I didn't know what to do. I tried a few different things and nothing seemed to work. So I put the computer into reset mode without powering it off, let it sit there for a while, and I'm going to put it back to run. The computer booted up and was working okay, and then I was just looking in the directory, and the same thing happened. It crashed and it halted. And this time it didn't even give me the plus prompt, so I couldn't even do anything. So I turned the computer fully off, turned it back on with doing the reset first, then tried to boot up. And unfortunately, it passed diagnostics and everything was fine. Then I hit enter to start booting Unix, and then it started, and right away it gave this SCSI error type 1. And that brings us to where we are right now. You can see there's that SCSI error type 1. And now, every single time I turn the machine off and on, or even just try to soft boot it, I always get self-test failed from the main board and this code 4F02. So I tried rebooting a few times, which is why you see it over and over again. It doesn't just try automatically. I power cycled the machine. And then what I did is I turned the computer off, and then I went and got dinner. So I let this thing kind of fully cool down for a while. And unfortunately, this most recent one right here, it was just right now, I just turned it back on, and it starts running the self-test and immediately fails. So there is clearly some kind of hardware problem on this board, and that's really scary to me. I was actually really excited to finally get to try to play with this computer a little bit, and I was going to try to load some software onto here. I was going to find the source code for something like Kermit and copy it over, like text mode, onto that machine, try to compile it, and then I was going to try to put a few more tarballs over there with source code for various tools and stuff, and see if they could be compiled and that kind of stuff. And yeah, the machine is just dead now. It does not work at all. So I'm not ready to throw in the towel yet. Let's open up the computer and start poking around in there and see if I can bring some life back into this thing. I'm hoping it's just a dodgy connection on a socket maybe. I don't know. I'm not quite sure what could be causing this. Well, the motherboard is back on the bench. And unfortunately, it's degraded even worse than it was just a moment ago, where it was failing the diagnostics. Now it doesn't even start. Now, I took a look at the reset pin here on the power connector. Remember I said this was the one that comes from the power supply? And very briefly, when I was fiddling with it in the computer, it actually started doing that boot loop thing again. And sure enough, that particular pin that I think comes from the power supply was going up and down, up and down, up and down between 5 volts and 0. Now what I haven't figured out is, does that reset signal on that pin come out of the motherboard and go into the power supply, or does it come out of the power supply and into the motherboard? I'm not totally sure. And I took a look at where this goes on the motherboard, just tried to trace that out. And it goes to the reset pin right here on the clock/CMOS whatever chip. But it also makes its way over to this MC1489, kind of similar to the serial ports, and it makes its way over to these resistors and these transistors here. So what could be happening is the reset signal comes out of the power supply, affects the clock chip here, and then goes into these, and these are like buffers that drive the signal all around the different parts of the motherboard for like different types of chips. Some chips are going to need reset low, and some are going to need reset high, and maybe that's what it's doing there. It's converting it into those two types of signals. Why aren't they using TTL logic there? I'm not totally sure. It's very difficult to trace all this because there's a bunch of traces that are underneath the layers. This board, I think, has 6 layers. Has the traces on the top, the traces on the bottom, then there's another set of traces on the top and the bottom, and then there's a ground plane and a power plane. I can tell there's both a ground and a power plane because when you look at the 5 volts and the ground on the power connector here, there are no traces coming off any of those pins, so they must be connected to internal planes. So a 6-layer PCB is really difficult to troubleshoot just because you can't see what's going on. I guess I should check to see if these are shorted, these transistors here. I think this has something to do with the reset circuit. Now the bad thing here is there appears to be multiple problems happening at the same time. This reset circuit thing, I think is related to what we saw in part 2, where the computer was boot looping. But the failed diagnostics, I think, is a completely unrelated problem. And even if I fix this reset issue, I think we're still going to get stuck with the failed diagnostics. All right, so checking these transistors, none of them are shorted. So the problem's not coming from that. I really feel that it's the pin 4 coming from the power supply. That circuit in the power supply is messed up. So maybe what I just need to do is just try to override that, and I'll just drive this to 5 volts, because it definitely seems like when this is held down at ground, that's when the computer just stays permanently in reset. I think what I'm going to do is I'm going to cut the trace for the reset signal that comes off the power supply pin, and then I'll add a bodge wire that goes from the pin on the clock chip, and I'm going to have it hang over the top of the motherboard. That way I can ground it or pull it to 5 volts relatively easily. So I'm just going to cut the trace right here, and it'll be easy to fix if I want to restore the motherboard back. Just put a bodge wire. Okay, that is not connected any longer. I guess while I have this out though, I'm just going to lift these chips, not the EEPROMs, I already took those out, but the CPUs and these various PAL chips. I'm going to pull these out of the board, and I'll maybe put a little Deoxit in there, and then I'll pop them back in. So if the reset problem can get fixed, and then the thing passes diagnostics by some kind of magic, then that would be awesome. Otherwise, I think we're up a creek. I'm just going to start over here and go methodically through all the chips. It was really nice that Plexus put all the PAL chips in sockets, and they used very high quality sockets as well. This whole computer is extremely well built and really easy to service, frankly. All but 2 of the PAL chips had the original labels on them, so when you see a sticker on a chip, you know that that's a PAL chip. Now, we know of the architecture of this machine. One of the CPUs is used for I/O, and the other one is used for jobs, which I think is the actual OS running. It seems the reset lines of these 2 CPUs is not connected together. That's what I was just testing with the multimeter. This is almost certainly because the computer boots up on one CPU and then loads code into, say, static RAM, and then starts executing the other CPU, so it releases the reset on that one later. While going through all the sockets and checking them, there was absolutely no corrosion or any pins that were bent or anything that was out of the ordinary. Everything looked completely perfect. Now on the back side of the board, I decided to take off the RAM card, inspect it, plug it back in just to make sure that maybe there wasn't a dodgy connection there, but no, everything looked just fine as well. All right, the motherboard is back in, and I have a bunch of stuff clipped on here. So what we have on the oscilloscope is 2 different probes. This one here, which is the yellow trace, is actually coming from the power supply. It's on that pin 4, the one that I cut. I forgot to hook a bodge wire up to the back. So what I did is I clipped onto the reset pin that's on the clock chip here. And that's what goes over here to these transistors and everything like that. That is the blue trace right here. Now what's funny is the power supply is currently connected to the back here, and the reset signal doesn't stay right around ground. It actually comes up to about, I'm going to say that's about 0.8 volts. If we unplug the power supply, you can see there it dropped down. All right, I plugged it back in and went back up. I think the reset circuit in the power supply is just bad. Something's wrong with it. So with things like this, if I turn on the computer, what's going to happen is, well, that reset line coming from the power supply is just noisy, but it doesn't, I mean, it's not doing anything. And then the reset line that's on the clock chip, the blue trace, is just stuck down at ground. So that means the computer's stuck in reset right now and it's not operating. And I think you can kind of tell that there's two LEDs lit, LED 0 and LED 8, which is kind of how it just works when you first turn this on, when the computer is stuck in reset. Now I have an 800 ohm resistor between these two clip leads, and it's on 5 volts on the power supply connector. So this end right here is 5 volts through 800 ohms. If I clip it onto the clip here that goes into the clock chip, that's the reset line, then theoretically the computer should come out of reset. So the blue trace should go up. Okay, it did, see, boop, right there. And right away the green light's on, and we got blinking lights on the front. And now number 2 is blinking. And by number 2 blinking, I am pretty sure that is exactly the same fault we had before we started, excluding the reset issues. This is that main board self-test failure results in this. And sure enough, there's the diagnostic error. I cleared the console, so we had a fresh start. Self-test failed, 4F02, same freaking error. I'm gonna turn this off because it's kind of noisy. So what did we figure out so far? Well, we figured out that the reset circuit is definitely handled by the power supply itself, and there's something wrong with the circuit inside the power supply. So I just bypassed it by doing this whole resistor thing, and theoretically, with a 555 timer, we could just replace the entire power supply reset circuit and maybe even hook it up to the switch on the front so you still have access to reset the whole system and just not rely on the bad circuit in the power supply. Now the problem is clearly we still have a fault on the motherboard, and I unfortunately have no idea what it is. Incidentally, before I took the motherboard out, I didn't show this on camera, I unplugged this SCSI cable. It's plugged in right now, but I had it unplugged, so it was just the motherboard on its own, and it was still failing that self-test in exactly the same way. And I also went and double checked that the voltage rails still look good, and all of them do, -12, +12, and 5 volts, nice and clean, no issues whatsoever. So I don't think we're having a power problem right now. We have a fault that has developed on this motherboard. Now it's quite possible the original documentation for the motherboard, the error code that we're seeing with the diagnostic might have like a pointer to what might be the problem. And that could give us a general idea of like where to look on the motherboard. Although without schematics, I mean, I can't really make heads or tails of anything on this motherboard. Now, even if we had an idea of what was wrong with this board, like say SCSI controller failure, there's nothing on the board that indicates that, hey, this is the SCSI controller. On a Macintosh, there's a SCSI chip. So you could just look to that in the logic that controls it. But on this board, the SCSI must be communicated with directly from the CPU. I guess that I/O processor, one of its functions is to communicate with SCSI. So it just has a bunch of TTL logic and PALs, I guess, that handle that. It's not done with an actual controller chip. The only controller chips there are the 4 serial ports back there, but those seem to be working well, at least the one that's displaying the console, and I just don't think it's necessarily related to that. Now it's possible maybe we have a bad CPU, like one that's failing. I guess I could swap the 2 chips around and see if that makes a difference. I did make copies of the ROMs, so I could make a fresh set of ROMs and put them in there. Maybe one of those ROM chips went bad, and that's simply a ROM checksum error. Although, now I think about it, I think when we were looking inside those ROMs in part 1, there was a ROM checksum or some checksum error messages that were in there. So you figure if it's booting up with a checksum error, it would have just said that. And if we think about the symptoms of what this thing had when the OS was running, I got bus errors, so it was crashing. And I don't think that's necessarily a RAM problem. I mean, that's just some kind of a logic problem on the motherboard. So maybe before I throw in the towel, let me try swapping the CPUs around, see if that makes any difference whatsoever. Because if one of them is slightly bad, then the error should be different, or it won't boot at all, or whatever. We should see a change. And then I can make a new set of ROMs. I'm pretty sure I have 27 128s handy, so I'll make a new set of ROMs. I'll swap those out. And then after that, I'm not sure what else to do. I guess I could like take all the RAM off and start testing that, but I don't know if that's the problem, because I recall in the diagnostic ROMs, when you look at them, there's definitely stuff that looks like RAM error. Although maybe not. Maybe this is just simply a RAM problem. So let me start doing some poking around with the CPUs and the ROMs on this side of the board, and we'll see if that makes any difference. Okay, I've done lots of stuff. So this is the RAM card, and I tested every single RAM chip. I went ahead and I used the DRAM tester that I had here that a viewer sent in. Thank you very much for that. And I tested every chip, and not a single RAM chip tested bad. I put a little mark on every single one that tested good, and they all did. In case anyone wants to see the RAM card on this thing, there it is. It's pretty typical stuff, just TTL logic and a whole bunch of DRAM. This is 2 megabytes of DRAM, and it all tested absolutely perfect. With the motherboard here, you might be noticing something here in this upper area. Well, I decided to use the Dremel to clear away the solder resist from the top of those traces, because remember, that was the battery damage area, and I just wanted to make sure that there was nothing broken. It can be really difficult sometimes to see if there's a via that connects to a trace, if that actually is broken. And so I cleared it all off, and I verified that every single via and trace has good continuity, and unfortunately it does. There was no issues up here whatsoever. That's not to say there's not a break inside the PCB, maybe like on a lower layer that I can't see. That is totally possible. But at least on this top side, no issues. Before I took drastic measures and tested all this RAM, which incidentally took a very, very long time, I did do some stuff on the board here. So I also checked that all 4 of the ROMs match. I didn't make new ones. I just took these out and I put them in my programmer here, and I verified that what I had already dumped when I first started this matched what's in these, and it does. It definitely does. I also took the CPUs out and swapped them around, and that didn't make any difference. I did figure out that the top CPU, though, is the one that runs the self-test. Without this one, you don't get any activity on the system at all. With the bottom one removed, doesn't seem to make a difference. I'm still getting that same exact failure message, and that happens whether this CPU is in there or not. I don't think it's even getting to that stage of the test. It's failing before it even gets to the second CPU, but this is the one that is running the diagnostics. There are some jumpers spread around this board, including these 2 right here. So just for fun, while this was installed in the system, I moved these over to a different position just to see what that would do. And that actually had an interesting effect, but not a positive one. You can see the diagnostics are failing here, main, and then we got SIO and a different code. And that happened when I moved those jumpers. And this happened even more quickly than the failure that says main with T4. I'm pretty sure that T3 and T4 means test 3 and test 4. And the reason why I say that is if we bring up the ROM here and we take a look at these diagnostics here, I think these are the tests in order. Test 1, test 2, test 3, that's the SIO failure, test 4, main, and then job, which I think is maybe the second processor, I guess, I don't know, map, which is the memory map, I think, or maybe mapper, is that, I don't know what the difference is here, then SCSI, then multibus, and we saw those failures previously, right? I released the multibus one when I was trying to troubleshoot those rebooting issues this thing was having. I think that was in part 2. Then clock, register, priv or private, parity, bus, prox, and no test, whatever that is. I'm noticing that none of these say RAM, but parity clearly has to do with the parity memory. Static has to do probably with the static memory that's on the board here. There's a bunch of static RAM. That probably tests in that section. And then bus must be like maybe a shared bus between the 2 CPUs or something like that. Prox, maybe the 2 processors to make sure they're running properly, I don't know. And then self-test complete. So at this point, I have found absolutely nothing wrong with this board. At least nothing that I can see is wrong. Now I have handled the board and I've obviously tested and reseated all the memory here. So what I need to do is put the memory card on this, put this back in the computer, and just verify that we're still stuck at exactly the same spot. And then we'll see what happens. Motherboard is back in. I haven't turned it on yet. I am ready to bring the reset line to high once the power stabilizes. And I cleared the scrollback buffer, so we'll see Plexus if it boots up properly, and then we should see, well, the error or it actually working. Now, the SCSI cable is disconnected from the motherboard. It's just the power cable. All of the other peripherals in the case are totally disconnected, by the way. Hard drive, interposer, tape drive, floppy drive, everything else is unplugged. It is literally just the power supply and the motherboard. So let's see what happens. Okay, system is on. I know you can't see me here. And I'm gonna clip the reset line on. Okay, there we go. It says Plexus. So at least I didn't break the thing. Oh, there we go. Same exact freaking error. So disappointing. That's so unbelievably disappointing. Well, this video certainly had some ups and downs in it. I was really excited to get this machine working, and then it all came crashing down now that it doesn't work. Now, you might think that I would say that this is the end of the series on this machine, but that's actually not the case. And that's because I reached out to the local community for some help with this thing to continue the troubleshooting process. A few things are in the works right now, and some of them are super exciting. One of them is we've started to analyze the contents of the disk, looking for, well, interesting information on there. And it seems that we've discovered a bit of a gold mine on the hard drive that's in this thing. I'll talk about that a bit more in a future video, so watch for that. Now, when it comes to the fact that this thing is broken, obviously the first thing we need to do is understand what the diagnostic ROM is doing when it fails. That's the first step in understanding what's wrong with this thing. So to that end, I've been talking to David over at Usagi Electric, and we created an Adrian's Digital Basement channel on David's Discord server. David's had really good luck with a lot of the obscure machines that he's worked on and got recovered and working again by relying on the community to help crowdsource some of the troubleshooting steps that are going to be required. So in that channel on David's server, we've already begun the work of disassembling the ROM that's in this thing to better understand what that's doing, and we have some interesting leads. If you want to join the party and get in on the fun of trying to reverse engineer some of the stuff on this machine, I'll put a link in the description below to the Discord server, so go click on that, join up, and catch up on what's there and see what the progress is. Finally, I just want to add that since part 1 has gone live, I've been reached out to by a couple people who either worked at Plexus or with Plexus during the time when these machines were being made, and that's filling in a little bit of the background information on what the company Plexus was. What's also really cool is some of the stuff that's on the hard drive that we're recovering also fills in a bit of those gaps. So I'll be able to do an episode or at least talk a little bit about the history of the company once I can kind of gather my thoughts and my notes together on that subject. So all that means that there is definitely going to be more videos on this machine. I want to get this computer working again, and I really want to get to the point where we can cross-compile code to run on this or even compile it on this machine. The C compiler is on here, plus the libraries and header files. That means it should be possible to at least compile stuff on this. But who knows? Maybe one day we'll get to the point where this machine can actually be emulated in QEMU, for instance, and there can be a Plexus P20 virtualization that you can use out there in the world. Anyhow, lots more to come, so get subscribed so you don't miss any of those updates. Don't forget to check below for the link to the Discord server that's set up now, or the Discord channel that is that's set up. Huge thanks to my patrons. Their names are scrolling up the side of the screen. They make it all possible that I do this full time, so I really owe them a huge debt of gratitude. Thank you very much again. You can become a supporter at the link in the description below. You get early access to videos and other stuff like that. Hit subscribe if you haven't already. Check out the second channel, you know, all the other YouTube junk. And I guess that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.